Hello candidates. Today I want us to go through a question which was done on 23rd of 23rd of August 2023, and the paper is Quantitative Analysis of CPA foundation level and SAFER foundation level. The question of interest is that which deals with normal distribution, and we find that question in question 5 at A, which reads, if I may just enlarge, which reads, the output of an acre of land is assumed to be normally distributed with an average of 52 bags of maize and a standard deviation of 3.2 bags required. The probability that the output of an acre of land is greater than 48 bags, that's 2 marks, is greater than 60 bags, 2 marks, is less than 45 bags, 2 marks, lies between 50 bags and 60 bags, that's another 2 marks. So this is the question of interest, is the question that we want to consider today, being that we are going topic based. This particular lecture focuses on normal distribution. That means the other bit, this part we'll consider in another video. So straight away, we dive to the solution and see how it goes. Hello, students. I want to look at this topic of normal distribution, which appears in the CASNEB syllabus, that is Certified Public Accountants Qualitative Analysis paper. So I will start by looking at the past question which tested the same concept, and that was question 5A, as you've seen, of 23rd August 2023. So it says the output of an acre of land is assumed to be normally distributed with an average of 52 bags. So that means we have average, that's the mean, is 52 bags of maize and a standard deviation of 3.2 bags. So standard deviation of 3.2 bags required. The probability that the output of an acre of land is greater than 48 degrees. So with these statistics, we remember the z-score is given by x minus mu over the standard deviation. That's the z-score. So x will be our observation of interest. Like in question 1, the probability that the output of an acre of land is greater than 48 bags. So that becomes our z becomes 48 minus 52 all over 3.2. And that should give us about -4 over 3.2. -4 over 3.2. And this is about -1.2. That's about -1.25. And you realize that that is the z-score that corresponds to this. So what we do is so a sketch would look like this to assist us know what we are doing. Yeah, like that. So that this here is that there is the mean. That's why we have 52. So I'm not doing a standardized one. A standardized should have had a 0 mean here, but because I'm still using my data, so my mean will be 52. And we are asked, so 48 should be here, this end. So let me just put it imaginary point to give space. So 48. Now, what we are asked is to get the probability that the output of an acre of land is greater than 48. So in that case, the area that we want is this particular this particular area, greater than 48, greater than 48, greater than 48. So we want this area. This is the area that we want, the area from here to that end. That's the area that we want. And we have seen that the area from here, from 0 to 48, if we ever had, it is possible to have no harvest at all. So from no harvest to 48, the z-score that corresponds to that probability is negative 1.25. So let's see what probability we read that corresponds to that z-score. So if you look at the tables, the standard normal tables, you'll see that the probability, if you read the probability that corresponds to a reading of 1.25, you'll see that it is about 0.8944. So let's see. We have that phi of negative z is given by 1 minus phi of z. So on that basis, it means that where phi of minus of z, that is phi of minus 1.25 will be, so that means that phi of minus 1.25 will be given by 1 minus phi of 1.2 of 1.25, like that. But phi of 1.25 is what we have read to be, if you read it from the table, I'm going to show you that towards the end of this class. Then, so 1.25, that corresponds to a reading of 0.8944. So this will give me 1 minus 0.8944. And this, the difference is 0.1056. So it means that the probability that corresponds to a z-score, that the probability that z is 1.25 or less, that is this or this, is given by this. So if we want the probability that it is greater than 48, we'll have to subtract this from 1, in which case it will come here. So that will be 1, this is now the required probability, minus 0.1056, which is 0.8944. So that's the probability, that's the answer at that particular end. So the next thing is to look at part 2. Part 2 of the question reads, part 2 of the question is greater than 60. Greater than 60. Now, greater than 60, part 2. Now we say z is this, as we had it before. And that then just implies that z is x, that is 60 minus mean, which is 52, all over 3.2. Now that difference, if you work it out, 60 minus 52, 60 minus 52 over 3.2, that difference should give you about 2.5. So it then means that the probability of a z-score being less than this is what we are going to get. So if I draw it, 60 will be somewhere, it will be slightly beyond the mean, beyond the average. So I may have it here, 60, 60, 60. So 60 is here, 60. That's 60. So if I want greater than, then it means that the z of 2.5 will define the probability from 0 up to 60. But being that I want probability from 60, from greater than 60, then having found the probability from 0 to 60, then I subtracted from 1 to get for this particular region. So the region of interest here is the one that is, if now I change it, it will be this now. This is now the region of interest. Yeah, the shaded part. So it's from 60 now, though this is still the mean. But now we are interested in the shaded region, So the z-score that corresponds to a reading of 2.5, that is the probability of z being less than 2.5, is about, if read from the table, as I'm going to show you towards the end of this lesson, is 0. So the probability that corresponds to this z value, that z is less than this, will be 0.9938. This value is read from the standard tables, and that's what I'm going to show you immediately before we wind up this class. So if that is the probability that it is between 0 and 60, then what is the probability that it is 60 and beyond? Then that will be 1 minus this. So the required probability in Roman 2 becomes 1 minus 0.9938, which should be 0.00 0.0062, 0.0062, and that's the required probability in the second instance. Now the third instance is less than 45 bags. Is less than 45 bags. That now becomes z is equal to x minus that over this, and then it means that less than 45 bags. So I say 45 minus 52 over 3.2, and that gives me, that should give me about negative 2.1875. Yes, negative 2.1875. So this is the z. So if we read the z value, if we read the probability that corresponds to this z value from the table, we'll actually get the probability that it is from 0 to 45. So we say the probability that z is less than negative 2.1 is approximately, if read from the table, here we read it directly and we don't have to subtract because it's just directly less than, meaning from here to here. If it were greater than, we would have subtracted going by the table, the loop of our table. So with this, then we read that that particular probability is 0.0. So the probability read is 0. From the table again, 0.0144. So this is just the probability that we want in Roman 2. And that's the answer for Roman 2. Now Roman 3 requires us to find that the probability that the output of an acre of land lies between 50 bags and 60 bags. So 50 bags and 60 bags lies between 50 bags and 60 bags. The picture will look like this, it will look like this, it will look like that, it will look like that. Yeah. So if this is 52, and we said it's between 50 and 60. So I would say this is 60. I would call this 60, and then call this 50. Call this 50, here 50. So it means that I want this area. I want this area. I want the area in between this particular area, the shaded part. That's the area that I want. Realize or remember that the total probability under this curve is 1. So this is how it proceeds. This is how we continue with it. So first here we have z of 50, in which case we'll be having 50 minus 52 over 3.2, and that gives us negative 0.625. So the z that corresponds to when it's 50 is this. Now the z that corresponds to when it's 60 will be 60 minus 52 over 3.2, and that difference is 2.5. So The probability that Z is this value or less, if read from the table, is so the probability that Z is less than this value is about 0.266. So probability that will correspond to a Z of 50 is I want to write it as such, will be about 0.2660 as read from the table that we are going to see towards the end. Then P's probability of Z60 will then be, if you check a value, probability value that corresponds to this Z, then you'll see that it's about 0.9938. So if we want to find this probability here, we would subtract this from this, in which case it is 0.9938 minus 0.2660, and that is, if you get the difference there, it is 0.7278, and that's the answer. So that marks the end of that particular question, and I urge you to subscribe so that you get free of such solutions. Up to there, see you in my next video. Hello, now I want us to look at our probability table, the normal distribution. This is the normal distribution function. It is, the function is defined by this particular curve that we see. So we are referring to the area. So the total area under this particular curve is 1, and they represent probabilities that corresponds to Z values that we read along the x-axis. So this phi Z represents the function of a normal distribution. Okay, I would have shown it, but now for this particular purpose, we look at this table and see that our first instance was to find where Z is 1.25, in fact negative 1.25. So we would come here and check Z here, 1.2 is here, this 1.2. Then we check, we move this way up to the point where I find 5. 5 is here. So at that point, I see that I have 0.8944. 0.8944, that's the value of Z that corresponds, that's the probability value that corresponds to a Z value of 1.25. Then for the Z of 2.5 again, we check, we come here and we see that if Z is 2.5, then straight away that's 2.50, then straight away we read 0.9938, and that is the value for part 2. Then part 3, we had the Z value to be negative of 2.1875. 2.1875. So 2.1, then we would find 8. We would 2.1, then we would find 8. So for this purpose, then we would find 8, then move to 7. So 8 is here. It's 1. It's okay. 8 is this. This is the column for 8. 8 column. So it was 2.18, which is this 7. So it's 0.9854. Then I again consider 7. Then I'll add this. So that will be 0.9857. If I subtract that from 1, because we are going on the other tail, the negative tail of our function or our table, then we would have to subtract this value from 1. That is 1 minus 0.9857, and we get about 0.0144, and that's the corresponding Z value that we want. Then when we get to 0.625, again this is negative, then we come here, 0.62 would be here. Then 5, you check, 5 is 16, you add that here. Then The same thing that we did, you subtract the value that you get from that, because it's 0.62. Then if I come under 0.625, so 2 is here, 5 I would have to get here, which is 16. So 0.324 plus 16 is 0.7340. 1 minus that should give you 0.2660, which is the probability that we obtained in our solution. Then another bit, yeah, that's all. The other one is 2.5, which we saw is straight away, being that is positive, it's just 0.9938. Now, what we should remember is that the probability values that we are given in this table correspond to a value, a probability between 0 and z. And that's why you see this probability is beginning from 0.5. This half is 0.5. This half is 0.5. You add it, it's 1. So that's it. And we'll still explore the properties and how you read this table in subsequent videos. Thank you.